with one note point and some stability analysis in this method, Euler's method, and after that Simpson's rule, trapezoid rule, etc. Okay. First of all, note, in this first method, just I have given previously order of convergence, here error order term. Method error order term. That means all these came by Taylor series only. So the Taylor series, you know that infinite series expansion, but we have considered in all these iterative formulas a finite number of terms only. That is definitely an error will affect. Okay. Euler's forward. Are not required. Modified Euler's order h cube. Please remember one more question. These are, because proof is neglected here, or if you refer to the textbooks, you will easily identify what is the meaning of error order term, all these things. Okay. Next, fourth order Range Kutta order h power 5. Please remember one more question. This 2. Stability analysis in Euler's method. Consider Euler's iterative formula, that is yi plus 1 is equal to yi plus h times f of xi comma yi. Say equation star. Convert star into the form yi plus 1 is equal to e into yi plus h times k, where k contain xi terms or k is a constant. Equation star is said to be stable, comma, if mod e less than or equal to 1. All of you please remember this condition. This method is stable whenever this mod e less than or equal to 1. What is this e? Once you bring your iterative formula into like this, into this one, then only you will identify e. Then whenever mod e less than or equal to 1, this method is stable. Otherwise it is unstable. Okay. You know the meaning of stable and unstable. So one problem I am going to do. 2003, 2 marks given. dx by dt is equal to 1 minus x by tau with step size delta t, capital T, greater than 0 to ensure the stability with step size delta t greater than 0 is evaluated using Euler's method full stop. What is the maximum permissible value of delta t to ensure the stability in the solution? Options: A, tau, B, tau by 2, C, 2 tau, D, 0. So generally step size we have denoted by h, it is given delta t. Instead of y and x, it is given x and small t variables. Okay. So given equation is dx by dt is equal to 1 minus x by tau. Replace x by y and t by x. We get our original notation dy by dx is equal to 1 minus y by tau. This is star and this is your f of x comma y. I brought into your original variables y and x, dy by dx, okay, by replacing like this. Now convert into this notation. Sorry, don't put the star. The Euler's formula, iterative formula is yi plus 1 is equal to yi plus h times f of xi comma yi. This is equal to yi plus h times, what is f of xi comma yi? In this, x is replaced by xi, y is replaced by yi, but it is absent of x. 1 minus yi by tau. And h value is also given in terms of delta t. So this is simplifies to yi plus 1, yi, how many times of yi here? Take yi terms common, 1 minus h by tau into yi, other terms are h into 1 by tau. Okay, so this is in the form of E, and this is in the form of K, where K is a constant or containing xi term. Okay, this is star according to our notation. See, what I told, stability analysis, convert your given equation, not given equation, your Euler's iteration formula star into the form yi plus 1 is equal to E into yi plus h into k, where k is a constant or containing xi term. Just look at your previous procedure. Equation star is said to be stable if mod E less than or equal to 1, implies what is mod E? 1 minus h by tau less than or equal to 1, and I have given this is mod x less than or equal to 1 means minus 1 less than or equal to 1 minus h by tau less than or equal to 1. Since in continuity limits chapter I have given this mod x less than L if and only if minus L less than x less than L. Now what is h is given? Step size. What is that? Delta t less than or equal to 1. Since h is step size, that is delta capital T. Now from this relation find delta t, that is eliminate this 1 and symbol minus and then tau. You find a range where delta t, that is you find range of delta t. Okay, that is delta t lies between two values. Then the starting value is least and the last value is ending value is minimum. So this is minus 2 less than or equal to minus delta t by tau less than or equal to 0. Multiplying by minus and tau, this becomes 2 greater than or equal to delta t by tau greater than or equal to 0. So this can be written as 0 less than or equal to delta t less than or equal to 2 times tau, since tau greater than 0. So here we have assumed tau greater than 0. Therefore, the maximum possible value, permissible value of delta t is 2 tau. Look at the options. Option C is there. I mean option B or option C? Option C. Just like calculus modulus inequalities and stability analysis mod E less than or equal to 1, where E is obtained after converting your Euler's method star equation into the form yi plus 1 is equal to yi plus, sorry, yi h into yi plus yi plus 1 is equal to e into yi plus h into k, where k is a constant or contain xi term. Convert your Euler's method formula star into yi plus 1 is equal to yi plus 1 is equal to e into yi plus h into k. So using this problem, the same type, using this method, the same problem which is also given 2009, 2 marks. Next, trapezoidal rule, evaluating definite integral from the tabulated values of function values fx. Trapezoidal rule. Integral a to b f of x dx. This a is also denoted by, in some textbooks, x0, b is also denoted by xn, fx is also denoted by y. Integral y dx is equal to h by 2 y0 plus yn plus 2 times y1 plus y2 plus y3 plus so on yn minus 1. I will give you y0, y1 separately again, which I already given x2, x1, x2, x3, x4, all relations in Euler's method, all these things. Next, Simpson's 1/3 rule. Integral a to b f of x dx. So this is also y. Again, a is denoted by x0, b is denoted by xn, is equal to h by 3 into y0 plus yn plus 4 times y1 plus y3 plus y5 plus so on yn minus 1 plus 2 times y2 plus y4 plus y6 plus so on yn minus 2. Actually, Simpson's 3/8 rule is not there, but formula I am giving. Only Simpson's rule means Simpson's 1/3 rule only. Integral a to b f of x dx is equal to 3h by 8 into y0 plus yn plus 3 times y1 plus y2 plus y4 plus y5 plus so on yn minus 2 plus yn minus 1 plus 2 times y3 plus y6 plus yn minus 3 . So these are also easy to understand, which are came in +1 level, +2 level, 11th and 12th standard. So in all these three, I am mentioning, I am giving what are h, what is h, what are y0, y1, y2 and x0, x1, x2, xn, like that. Where H is length. In sometimes depending on the problem, this is also width. Depending on the nature of the problem, this is also called size. Each of the subinterval after dividing closure interval a comma b into n equal parts, that is h is equal to b minus a by n. In some textbook this is xn minus x naught by n. A is lower limit and b is upper limit. This b is some textbooks xn, a is some textbooks x naught. Now what is your step size formula? Length or width after dividing your entire closed interval a comma b into n equal parts. Then h is equal to each of the subinterval length b minus a by n. A is lower limit, b is upper limit. Okay. Y naught is equal to f of x naught. Y1 is equal to f of x1. Y2 is equal to f of x2. Y3 is equal to f of x3. So on. Yn is equal to f of xn. X1 x0 plus h, as I already given these things. X2 x1 plus h. X3 x2 plus h, so on. So numerically only we are evaluating. Okay, in only 5% problems you may get exact answers. Just like in Euler's, yesterday's Newton bisection method, we got in 3 steps only exact root. Okay, but all these are approximations only. So in trapezoidal rule, in all these rules, trapezoidal first is h by 2. In Simpson's 1/3 rule, h by 3 outside term. In 3/8 rule, 3h by 8. Now coming to 1 by 1 inside terms. The first bracket y0 plus yn, that is adding end values of y, and other all values multiplied by 2, that is trapezoidal rule. In Simpson's rule, after end values y0 and yn adding, then odd suffixes y1, y3, y5 all are multiplied by 4. Even suffixes y2, y4, y6 all are multiplied by 2. That is the hint I am giving how to remember easily. Just logic or shortcut I am explaining. In 3/8 rule, after adding y0, yn, that is end values, all except multiples of 3, that is y3, y6, y9, etc. remaining all multiplied by 3, and these multiples of 3, that is by 3/8 rule, y3, y6, y9, etc. these are multiplied by 2. Easy to remember. Example, first problem. Which is given 2006, 2 marks. A second degree polynomial comma fx has values of 1, 4 and 15 at x is equal to 0, 1 and 2 respectively, RESP respectively, the integral 0 to 2 f of x dx is to be estimated by applying trapezoidal rule. TR stands for trapezoidal rule to this data. What is error? Defined as true value minus approximate value in the estimate. So true value means the value obtained by analytical method, that is by doing by integration, exact value, that is also called. Approximate value means the evaluation of the integration by trapezoidal rule, because it is mentioned trapezoidal rule. So let me evaluate first trapezoidal rule. Here x0 0, x1 value 1, x2 value 2. And y0 value, that is f of x0, which is also given 1, y1 f of x1, that is 4, y2 f of x2, 14. Not required to h, and h value, difference of the consecutive x values, that is 1. Between 0, 1, 2, what is the difference? H is equal to 1. By TR, what is TR? Trapezoidal rule. Integral 0 to 2 f of x dx. Formula is h by 2. Only 3 function values. Y0 starting value, ending value is y2. That is last value of y. Plus 2 times of remaining is y1. Okay. Here also I can write according to our notation the last value y2 here. y2, which is our notation yn. x2 according to our notation, this is xn, because last value 3 values are only given. A is equal to lower limit, b is equal to upper limit 2. Now substituting here h value 1 by 2 into y0, 1 plus 15 plus 2 times of 4. So 16 plus 8, 24 by 2, this is 12. Since f of x, now I am doing by analytically, exact method, using integration, is a second degree polynomial therefore fx is in the form of a0 plus a1x plus a to x square. General second degree polynomial I have taken. Now what are 3 y values and 3 x values are given? So y naught is equal to f of x naught is equal to how much? 1. This simplifies. In f of x naught substitute x naught value how much? This is 0. So y1 value is nothing but f of x1. Your x1 value is 1, whose y1 value 4. And y2 value is given that f of x2, your x2 value is 2, whose value is 15. Let us say this is equation 1. Therefore 1 implies, substitute these 3 conditions as above. A naught, A1 0, A2 0, that is A naught is equal to 1. Next, substituting this condition there. A naught plus A1 plus A2 is equal to your fx value, that is f of x1 value 4, which simplifies to A naught 0, A naught 1, A1 plus A2 is equal to 3, equation 2. And substituting that third condition, A naught plus 2A2 plus 2A1 4A2 is equal to corresponding y value 15. A naught is given 1, A naught we got 1, and then after taking 2 common, cancelled with the right side, this simplifies to A1 plus 2A2 is equal to 7, equation 3. Solving 2 and 3, we get A1 is equal to, just subtract, A2 is equal to 4, A1 is equal to minus 1, A3 is equal to 4, sorry, A2. So therefore your fx is equal to 1 minus x plus 4x square. Now analytically I am integrating, that is your formula based method, not trapezoidal rule method. Integral 0 to 2 f of x dx is equal to integral 0 to 2 1 minus x plus 4x square. One integration with respect to x is x. X integration is x square by 2. X square integration is x cube divided by 3. Substituting the limits 0 to. Therefore integral 0 to 2 f of x dx is equal to upper limit 2 minus 2 square by 2, that is 2 minus 2, 2 cube 8, 4 into 8, 32 by 3. With lower limit all x terms, after substituting lower limit 0, it becomes 0. So this is simplifies to 32 by 3. So this is true value, that is also called exact value. And this is approximate value. Please go back again. While evaluating numerically by trapezoidal rule, the value so obtained is called approximate value. While using integration standard formulas, analytically that value obtained is called exact value. So therefore error is equal to true value, that is 32 by 3 minus approximate value, which is defined in the given question, 36, that is minus 4 by 3. That is the answer, error. Error is defined as exact value minus approximate value. Exact value is obtained by analytical method, that is integration method directly. Approximate value is obtained by numerical method, by that is trapezoidal rule or Simpson's rule, but the method is mentioned trapezoidal rule. So with the above, only using trapezoidal rule, 2 marks given 2013, with the data is given without evaluating fx. Function fn, function f is known at the following points: x value, other row is fx. Zero, 0.3, 0.6, 0.9, 1.2, 1.5, 1.8, 2.1, 2.4, 2.7, 3.0 is also given, whose values are obtained here, calculated: 0.09, 0.36, 0.81, 1.44, 2.25, 3.24, 4.41, 5.76. Just square off these numbers. Other two values: 2.7, 3.0, that is 7.29, 9.00. Compute using the trapezoidal rule TR the question is now the value of integral 0 to 3 f of x dx computed using trapezoidal rule is, just I am giving the answer, later you check. You have not evaluated two function values, you need not evaluate the function value which is given. So this is y naught, this is yn. Yn means how much? See, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 values are given. So this is y naught, this is y10. Okay, h value, differencing of two consecutive x values. Your h value is 0.3. Okay, hint, h value is equal to 0.3. Okay, y0 0, y1 0.09, y2 0.36, so on. Y10 is equal to 9.00. That is a hint. Using this hint as above, that is the trapezoidal rule. Don't find analytically. Here fx is we don't know. Numerically only, by trapezoidal rule only you need to evaluate. In the previous formula I have given the formula.